Okay, guys, can you hear me clearly?
Sure, yes, 老师。
Okay, so from today we will learn the next chapter, chapter 3. And so first, in this chapter we will learn differentiation about derivative, calculate derivative. And so first we will learn rates of the speed. So let me write the title, chapter 3. And first we'll learn rates of speed. So we will learn average and sorry. We will learn average speed. So what is average speed? That is, for example, there is an object, maybe a man, and he is running on the street. Maybe this is a street, and he will start from here, and the time here, that is t sub 0, and he will run to this the distance from here to here, that is the time from t0 to t. And if we suppose this is a function, that is the function of distance over the time, that is we can suppose s equals to f of t. So here we know that is the distance that is from ft0 to s1 f of t1. So now I want to know the average speed of this man, and he is running, he moves in a variable speed along the straight line. So here we know that if I want to know the average speed, that equals to, we use f of t1 minus f of t0 and over t minus t0, right? So this is the increment of the distance. Here it is the increment. We have learned that increment of the function or the distance. And this is the increment of the time. And as we know that if I use the increment of the distance over the increment of the time, then we can know the average speed. But if I want to know the speed at the time t0, so how I can get the speed now? The speed that at this time, this moment. So here we want to know how to calculate this speed. So if I can write, I can let here that t minus t0 here, that equals to delta t as v, and ft1 minus ft0 as delta s. So here, the average speed we can also write as delta s over delta t, right? So if I want to know the moment t0, so we know that is delta t approaches 0, right? But we cannot use this formula because here denominator cannot be 0, right? So here I want to calculate if delta t approaches 0, so how I can calculate it. So now we will use the tool we have learned, that is limit. Limit. So I can let delta t approaches 0. And if now the limit as delta t approaches 0, delta s by delta t, the limit exists. And we know that stands for the speed for this moment. So here I get a expression, and this expression I can write as another type that here I will give you. So here I will give you a function that is y equals to f of x. And now we have the expression that is limit as delta x approaches 0, then delta y by delta x. Or here we know delta y equals to fx minus fx0, and delta x equals to x minus x0. So here we know if I change this formula that to x equals to x0 plus delta x, right? I can move x0 from right to left. So I can get this formula that is x equals to x0 plus delta x. And here, delta y, we have another type to express that is f of v. Substitute x here. So that is x0 plus delta x minus f of x0. So this expression has another type that is as delta y now, that is f of x plus x0 plus delta x minus f of x0 over delta x. And as delta x approaches 0, so now if this limit exists, that stands for the rate of the change. And yeah,
I have a question.
yeah.
How can I get from data x equal to x minus x0 to x equal to x minus 0 plus data x? How can I get this one?
This one?
Yeah. Yes, this one.
Here, from this example here, I have gave you the start point. And this is the start point, time, moment. This is the end moment. So we can get the increment of the time. And for this function, we also gave you the start point, that is x0.
Yeah.
And this is the end. This is the end. So we have the increment of x, right? So here we can delta x.
I did not say that. I said that how can I get?
Yes, I know.
From this.
Here to here, right?
From this to this one.
Yeah,
this
yeah,
one.
yeah.
How can I get?
Yeah, moment.
Because it will not be plus.
Listen to me, listen to me. Okay, I am explaining, okay? So here you can see delta x equals to x minus x0, right?
Yes.
So
yes.
Here I put this part from right to left.
Yeah.
So I can get x equals to x0 plus delta x, right?
If I put this in the left side, then it will be minus x0. So how can be it plus?
Well, which one is minus? Here, I will write again. Please remove the circle, okay? So here you will see that delta x equals to x minus x0, right?
Yes.
And we plus x0 on both sides, right? We plus x0 on both sides to make it equivalent, right?
Okay.
And
Yes,
on
right.
the right, minus x0 plus x0, they can be cancelled, right?
Yes.
So here we get x equals to x0 plus delta x, as I write here.
Got it, Laushi. Got it. Thank you, Laushi.
Welcome. Okay, we will continue here. So here we get another type of the limit of the expression. So in math, here we call it if the limit here exists, so we can call that the limit, it is the derivative it is the derivative of the function at the point x0, and we will give it a sign. We write f prime x0. So this is derivative, the definition of derivative. So you have to remember that the derivative, actually that is a limit. That is a limit. And here we will use this symbol to stand for derivative. And more here, because we have read that here delta x equals to x minus x0, and as x approaches 0, we know that is delta x equals to x minus x0 approaches 0, right? So we know that means x approaches x0, right? And here delta y, that equals to f of x minus f of x0, and here if x approaches x0, we can write it as another type, that is as x approaches x0. Here I write like this, x approaching x0, and here I will write fx minus f of x0 by x minus x0. So here I will write the expression of the derivative again, that is f prime x0. We have three types. We have three expressions. They are the first, as delta x approaches 0, delta y by delta x. And the second, that is, as delta x approaches 0, f of x0 plus delta x minus f of x0 over delta x. And the third, that is, as x approaches x0, f of x minus f of x0 by x minus x0. So these three expressions are equivalent. They are all stand for f prime x0. That means the derivative of the function f at the point x0. So here, that is the definition of derivative. And if a function that can have the derivative at every point of an interval, we call that the function that is differentiate at this function, at this interval. So here we can write like this: f prime x equals to limit x approaches x0, fx minus fx0, x minus x0. So here we know that is this expression, and we use this expression most. And here there are other symbols for derivatives. For example, the first one we often use, that is f prime here. And the second we often use, that is d, that stands for differentiate. So here we use dy by dx. dy by dx also means derivatives, or we can use d f of x by dx, or we don't write x here, df over dx. They all stand for derivative here. So you have to remember these symbols, and we call it the derivative of the function f with respect to x. So here is the question: how can we calculate the derivative, or how can we calculate the rate of the change from this definition? For example, here we all know a function that is a constant function. We always use f of x equals to c, right? This is a constant function. C is a constant. And here I want to know that f prime x, or we can write, because fx equals to c, so here I can also write c prime. So here I want to know the derivative of the constant function. So how to calculate from the definition? Now we will solve it. By the definition, you should remember that is a increment of the function over increment of x, and we calculate the limit. If the limit exists, that means the derivative we can calculate. So here, that equals to limit as x approaches x0 and f x plus delta x by f of x over x minus x0, or here I can write delta x here. So here we can use this definition to calculate the derivative of this constant function. The first step we have to calculate here. So we have to calculate delta y, as we have read that delta y equals to f of x plus delta x minus f of x, right? So here we know this is a constant function. That means no matter which value you put in this function, that always equals to c, right? So here, f of x plus delta x equals to c, and f of x also equals to c. So we can get delta y that equals to c minus c equals to 0. For example, you can see here. For example, this is the graph of the constant function, and maybe this is a constant c. C can be 1, 2, 3, and more. Here you can see maybe this is the point x, and I will give it an increment. So here, this point, that is x plus delta x, right? So you can see the value of x, that is c, right? And the value of x plus delta x, that is also c. So we can see that is c minus c equals to 0. And now we will calculate the second one, that is delta x. And delta x, that is always delta x, right here, as we know, that equals to the terminal x plus delta x minus the start x. So x can be canceled, that is delta x. And the third step, That is, to calculate the limit as delta x approaches 0, delta y by delta x. So that equals to 0 over a constant, right? So that equals to 0. So we know the limit exists and the value is 0. So we know f prime x, or we can write c prime equals to 0. That means the derivative of a constant equals to 0, no matter which constant. For example, the derivative of the constant 2 equals to 0, and the derivative of the constant square root of 2 also equals to 0. And the derivative of the constant maybe 100 that also equals to 0. So this is the first example. We use the definition to calculate the limit of the function. So here, do you have any questions about this one? No? No questions, right? So yes. Okay, so here we know that the first formula we have to remember, that is this one. The derivative of a constant equals to 0, And second, we will use the definition to calculate another one. That is, now I will give you the function that is f of x equals to x. That means f1 equals to 1 and f2 equals to 2, and so on. So now we will differentiate this function. That is, we will calculate f prime x that equals to x prime equals to which one? So here we also use the definition. And from the definition, if we want to calculate the derivative, we will follow the following 3 steps. The first one, that is, we will calculate the increment of y, right? And the increment of y equals to f of x plus delta x minus f of x. So here, can you tell me, guys, f of x plus delta x equals to what? The function that is f of x equals to x.
C.
X.
X.
X. F of x plus delta x. Look at here, f1 equals 1. F2 equals 2. Here, I will give you an example. F of 1 plus 1 by 2 equals to what? Equals to 1 or equals to 1 plus 1 by 2?
Equals to what?
1.
Yes.
X plus delta x.
Here, this is the function. That means the value
X plus
of f equals to the variable, right? So here I gave you 1 that equals to 1. I gave you 2 that equals to 2. I gave you 1 plus 1 by 2. That should equal to 1 plus 1 by 2, right?
f of x plus del x equal
3 by
x
2.
plus del x.
3 by 2, right? 3 by 2.
Yeah.
Yeah. So here, f of x plus delta x should be equal to x
X plus delta x
delta x, right?
minus x.
Yeah, minus x, because f of x equals to x, right? So
Yes.
here, x can be cancelled. So
Equal
that
delta x.
equals to delta x.
Delta x.
Yeah, and the second
Yes.
step, delta
Here
x,
also.
that is delta x, right? We don't change it as above here. So here we will calculate the limit, that is as delta x approaches 0, delta y by delta x. That equals to the limit as delta x approaches 0, as we know here, delta y equals delta x, right? So we put delta x here, and delta x, that is still delta x. So delta x can be cancelled. The limit equals to 1, right? So here we have the conclusion that the derivative of the function f, or we can write x prime that equals to 1. X prime equals to 1. So about the second example, any questions?
No, Loshi.
Okay. So here, from the first example, I have gave you the first formula or the first rule. That is, the derivative of the constant equals to 0. And from the second example here, I will give you another rule, or we can call it the power rule. So here, I will give you another rule. Here, maybe that is rule 1. And here, that is rule 2. We call it power rule. That is how we can calculate x power n prime. So here the formula, that is x power n prime equals to n times x power n minus 1 here. So we can test here x prime. X prime means here x power is 1, right? So from this formula we know that is x power 1 prime, and that equals to here, that is 1, right? Times x power, that is 1 minus 1, that is 0, right? 1 times x power 0, and we know x power 0 equals to 1, right? So 1 times 1 equals 1, as we have calculated here from the definition.
Can you repeat, please, this line?
Okay. The second line, I want to check the rule 2, the power rule. So we use this example. From the definition, we have calculated that x prime equals to 1, right? So
Yes.
Here we will use rule 2 to check if x prime equals to 1. So here we check x here, x prime, that means x here power 1, right? Power 1. And here that means n equals to 1, right? And we use this rule that equals to n times x power n minus 1, right? So here we know n equals to 1, so 1 here. And times x power n minus 1, so here n equals to 1, that is 1 minus 1. That equals to 1 times x power 0 here, right? And x power 0 equals to 1, so we know the result is 1. As we calculate here, they are the same. Can you understand? Or I will give you another example here.
Yes, Loshi.
Okay. Another example.
Loshi, the first rule was f prime x equals to c prime equal to 0. It was the first.
X prime, which one? Power here?
it was the first rule, and the second rule was f prime x equal to
the
x prime
first
equal
rule,
to
we
1.
cannot use it. The first rule, that C is a constant. Constant means 1, 2, 3, 4.
Yeah, shit.
It cannot change, right?
I
And
just
here
want to know the rule 1 and rule 2.
Okay, rule 1. Here is rule 1. And
Yeah, I got it. Like,
okay.
I just want to check it. Like, it is
Okay,
right.
okay. So now I will give you another example to use rule 2 to calculate the derivative of a power function. Here, if now I want you guys to calculate x squared prime. So now, follow my steps. We use this rule here, n equals to 2 now, right? So now we use the formula here that equals to 2 minus times x power 2 minus 1, right? Can you understand? We use this rule.
Yes, yes.
Yeah, this is a
Rule
very
number 2.
basic. Yeah, this is a very basic formula. So you have to understand. So here, first, n, if n equals to 2 here, x squared, right? So we use this formula that is 2 times x power 2 minus 1. We substitute n equals to 2 here, right? And that equals to 2 times
X power 1.
yeah, x power 1. So mostly we don't write it, right? So now we know x squared prime equals to 2x. So here we know x squared prime equals to 2x. Can you understand?
Yes, Laushi.
Okay.
Yeah, Laushi.
So try to calculate x power 5 prime equals to what?
Okay.
5x.
Let me solve.
5x, Laushi.
5x? No.
5x to the power 4.
Don't forget the power. Don't forget the power.
It's 5
5x power 4.
power 4.
Yeah.
5 into x to the power 4.
Yes.
Yeah. 5 into x to the power 4.
Yeah. So here we use the power rule now. That is n equals to 5 now, right? So x power 5 prime equals to 5 times
Into
x and power 5 minus
1.
1. So that equals to 5
5x power 4.
x power 4. Yeah, can you understand, guys?
Yeah, Laushi.
Yeah, Laushi.
Yes.
Yeah. And another one that is square root of x prime equals to 1.
Root x divided 2.
Root.
Laushi. Root x divided 2.
Please send your procedure.
Okay.
On WeChat, Laushi?
Yeah, we check.
Okay.
Yeah, here, as you know, that here n equals to 1 by 2, right? So we can use the formula that is 1 by 2, x 1 by 2 minus 1, right? So that is 1 by 2, x power minus 1 by 2. You can write as this one, or it can be written as x power minus 1 by 2. That is 1 by square root of x, right? So here, that is 1 by 2 times square root of x. So this is the correct answer. Here, x power minus 1 by 2 equals to 1 by square root. So this is the answer. Can you understand, guys?
No, Lordship, please repeat again.
I cannot understand.
Yeah,
Which
Lordship,
one you cannot
understand.
understand? Here, we use the power rule here. The power rule, I think you can remember, right? That is x power n prime equals to n x power n minus 1, right? Here, square root of x, that is x power 1 by 2, right? X power 1 by 2. So here, yeah, so here we know that n equals to 1 by 2. N equals to 1 by 2. So we can use the formula that is n 1 by 2 times x power n minus 1. So here that is 1 by 2 minus 1, right? So that is minus 1 by 2. So here, we got this step. And then x power minus 1 by 2. That can be written as 1 by square root of x. We can write like this. That is x power 1 by 2 power minus 1. And inside this one, that is square root of x. And power minus 1 means 1 by square root of x. So here we know the final result, that is 1 by 2 times square root of x. Here, that means 1 by 2 times 1 by square root of x. So we can get, that is 1 by 2 times square root of x. Can you understand now?
Yes.
Yes, Lordship.
Okay, this is a different type to write the power. We can use the square root, or we can use the power half here. So this is the second rule, power rule. And as these two rules, we have other formulas to calculate the derivative, because if I give you a function that is complicated, then maybe we can use the definition to calculate, but that is very hard. That is very difficult. So I will give you some common formulas, and for you, you have to recite, you have to remember these common formulas, and we can use them directly in the calculation. So here I will give you some very important formulas, and you have to remember, write them down and remember them. So the first one, that is, we have constant prime equals to 0. And the second, we have, that is the power rule. x power n prime equals to n times x power n minus 1. And the third, that is sine x prime, and that equals to cosine x. Sine x prime equals to cosine x. For these formulas, you can prove by the definition. They can hold. So if you are interested in the proof, you can prove it by yourself. So, and following number 4, that is cosine x prime, that equals to here minus sine x. Don't forget the sign minus here. I will use a red color to emphasize. And number 5, that is a, the base is a, power is x prime. That equals to ax times ln a. We have learned ln function. Pay attention to number 2 and number 5. They are different. Number 2 means x power 2 prime equals to 2x. We have calculated, right? And here, number 5, that means 2 power x. Here, these two functions, they are totally different. And prime, here, that equals to 2 power x times ln 2 times ln 2. So these two are totally different. And number 6, that is a special case of number 5. That is, the base is e. The base is e, and here e power x prime equals to e power x. The same function. We don't change it. And number 6, that is log function to the base a of x. Here, prime, that equals to 1 by x times ln a. Sorry, number 7 here. And number 8, that is a special case of number 7, that is ln x. We know ln x means log function with the base a equals to e here. So ln x prime equals to 1 by x, because ln e equals to 1. So here are 8 common formulas we often use, especially number 1, 2, 3, 4, 6, 8. These six formulas we often use to calculate the derivative of a function. So you have to remember them very well, and you can use them directly.
Laushi.
Yeah.
Why we are using the prime sign? Why can't we use d by dx to using this formula?
Use which one? Use which formula?
Like this, d by dx, and then
d by dx is a factor, maybe,
like
not
this.
a formula.
We don't have a formula to calculate sine x. C is a constant.
No, Laushi, I'm just explaining, like, why don't we use d by dx?
D by dx, yeah, it's a
instead
factor.
of prime.
Of course, you can write like d by d. That is also okay.
That's what I'm asking, because prime we can get confusing with prime because we have a lot of
course.
primes too.
Everyone.
We are used to d by dx.
Yeah, Laushu, we are used to d by dx.
Okay.
We use d divided by x.
So you have learned in high school, right?
Yeah,
Okay. Okay. So that is also okay. You can write like, for example, maybe d by dx cosine x. Yeah, that is okay. They have the same meaning. They have same meaning because I think prime that is easier to write. So we also use prime to write.
Yeah, Laushu, it's
d by
easier,
d,
but
that is also okay. That is from the definition of differentiation, right?
yes, Laushu.
Yeah, it's okay. So have you written all the formulas? So now I will give you some examples.
Yeah, Laushu.
Okay, so I will screw up. So now I will give you some exercises. The first one, all the exercises, I want you guys to calculate the derivative. So the first one, that is x power 20. Second one, 1 by x. The third one, 1 by x power 4. And number 4, that is 5 power x. So please calculate these 4 derivatives. So could you please remove the writing?
What, Laushu?
Okay, thank you. Okay. If you have finished, you can send your results to the WeChat group and I will check.
Kunda. How should I send it to you all?
Okay, I'm checking one by one. Okay, I see most of you have finished, but number 3 and number 4, some of you did wrong. So we will see here. For the first two, they're easy. First, that is x power 20 prime. So that equals to 20 x power 20 minus 1. So that equals to 20 times x power 19. So this is the first one. And the second one, 1 by x prime, that equals to x power minus 1, right? Prime. So here we know that equals to minus 1 times x power minus 1 minus 1. So that equals to minus 1 times x power minus 2. And here we often write it as minus 1 by x squared. So here we often don't write minus 1 here. We just write minus here. So here, please pay attention to this point. Okay, this is the second one. And number 3.
Laoshi, how can I get e square? X square.
Minus square.
If x inverse 2, 1 divided x square.
Yeah. X minus here. X power minus 2. That equals to x squared outside power minus 1, right? So that
okay.
equals to 1 by x squared.
Got it, Laoshi?
Got
it.
Here, and here that is minus, here is minus. So x minus 2. Here, if the power that is negative, that means we have to do it, we can take minus 1 outside and to take it by 1 by x squared. And we always apply it on like this one that is 1 by x power 4 prime, right? And here we know 1 by x power 4, that can be written as x power minus 4, right? Prime. So that, x power minus 4 here. So here we can use the power rule, that is minus 4 times x minus 4 minus 1, right? So that is minus 4 times, moment, I will write it, x power minus 5. So here we often write like minus
4 divided x power 5.
Yeah, x power 5. We often write like this. So what is the question?
Number 2. Explain again.
Oh, okay. Number 3, right? Number
2 and 3. 2 and 3.
2 and 3. Okay.
Yeah.
Number 2, you give us one rule, that means log x equal to 1 by x. So why we can't write here?
That is the derivative. Okay, where is it? Here.
Number 8.
Yeah, that is the derivative of ln x equals to 1 by x. That does not mean 1 by x prime equals to ln x. Can you understand? This is the rule. This is the rule. This is the function. The derivative of the function ln x equals to 1 by x. But the derivative of the function 1 by x does not equal to ln x.
So which rule we are following in this case? Which rule we are following in this case?
We can only use this formula as the function is ln x. So you can use the formulas just as if I want you to calculate the derivative of a constant that equals to 0. I want you guys to calculate the derivative of the function cosine x that equals to minus sine x. You can just from the left to the right. We can just use. Okay.
Good morning.
Good morning, Zhou Shang.
Okay. Okay. Good morning. Good morning. Okay, here. So you can just use the formulas from the left to right, but you cannot use it turn around. But for number 6, of course, e power x prime equals to ex, right? So that they are the same. They are the same. But others, you can just only use it from the left to right. But the converse is not correct. So here, remember that does not hold. Okay, so although we
sorry for interrupt. I have a question to my Bangladeshi friends. Here prime means d by dx.
Yeah.
Yeah.
Okay, I have a confusion.
You can use both prime or d by dx.
Of course,
doesn't matter.
Right? Like.
See, Laoshi, I told you that prime will make us confused.
Yeah. Okay.
Yeah, we also faced a little bit problem with prime.
Okay. So here, that is dx by dx. So now we will try to explain number 2 and number 3 again for number 2. Number 2, I will write it again here. Number 2, now I want to calculate 1 by x by dx here. And that equals to here, that means
x inverse 1
minus 1, right? So
yeah.
we use the formula here, n equals to minus 1 here, right? So that from the formula that is
minus 1 into x minus 1 minus 1.
So here that is minus 1
minus 1 into x inverse 2
minus 2. And for this expression, we often write like minus 1 by x squared. They are equivalent. But we always write like this. It is more clear to see, right? So this is the result of number 2. So now can you understand number 2?
Yeah, Laoshi.
Okay, so for number 3, here the power is minus 4, right? So here, number 3, d 1 by x power 4, and that equals to x power minus 4.
Minus 4.
Yeah, so here we use the formula n equals to minus 4.
Minus 4.
Yeah, so that equals to minus 4 times x power minus
4.
Minus 1. So that equals to minus 4 x power minus 5. So we often write this expression like minus 4 by
divided x power 5.
Right. These two expressions are equivalent, but we usually write like this. So this is the result.
Yeah, thank you.
Can you understand?
Yes.
Yes. Okay. So
Yes,
the last one, number 4. Number 4, that is dy by dx. Here, y equals to 5 power x. So we use the formula here, a power x by dx equals to what? Can you remember that? Power x
over x ln x ln a.
Yeah, times ln a, right? So here, we know a equals
5 to the power x ln 5.
Yeah, so that equals to 5 power x times ln 5 here. We just substitute a equals to 5 into this formula. So we can get the result here. This is the result of number 4. Any questions?
Nah, Laoshi.
No.
Okay. So here from so here from the definition, we know that the definition of the derivative, that is a limit, and the expression for the limit, that is delta x approaches 0, f of x plus delta x minus fx
F of x divided delta x.
Delta x, that means d
divided dx f of x.
Yeah, and as x equals to x0, right? So if I write here, I think that is not as easier as f prime x0, right? But you guys like this symbol, right? So they have the same meaning. So here we know prime derivative here, that is a limit. And for the limit, we have left-hand limit and the right-hand limit here, right? So also we will have left-hand derivative and right-hand derivative. So now I will give you left-hand derivative and right-hand derivative. If the limit and delta x approaches 0 from the left exists, that means the left-hand limit exists. Then we call it left-hand derivative. And here we often write negative here. That means left hand. And if the right-hand limit exists, we call it right-hand derivative. So here we write plus here. So now we know if we say a function is differentiable at a point, that means the derivative at this point exists. That means the left-hand derivative exists and the right-hand derivative exists, and they have the same value. So this is the way to check the derivative. So here we have to know that is also because we have left hand and right hand limit. So we also have here that is left hand derivative. And here that is right. So you should know it. And then last week we have learned continuous. Remember that? last week we have learned continuous, and I give you and a function that is the absolute function, f of x, absolute value of x. And last week we have proved that the function is continuous. That means the graph, if you can draw the graph of a function, for example, for this function, absolute value function, the graph that is like this. And as you can see, for the graph, there is no hole on the line, right? So it is a continuous function. It is a continuous function. Every point that is continuous. But now you should know that the function, the absolute value function, is not differentiable at the point 0, 0. That is at the origin. But the function that is not differentiable at the point origin here.
Why, Laoshi, it is not differentiable?
Yeah. So now we will prove it. So here we will use the definition. We will use the definition of the derivative. So here, as we know, I can write the function as here, these three parts. If x is larger than 0, that equals to x, right? And if x equals to 0, that equals to 0, right? And if x is smaller than 0, that is minus x, right? So here, you should know that if now we consider the right hand derivative, that means now I will consider from the side right. That means larger than 0. And now the derivative of this function equals to x prime, right? Because now x is larger than 0. And that equals to, remember that x prime equals to 1, right?
Yeah.
If now I consider the left-hand derivative, that means x is smaller than 0. So now left-hand limit or left-hand derivative here, that is minus x, right? Minus x prime. So now that equals to minus 1, right? Can you understand minus 1 here?
Yes.
Yeah.
Yeah.
So you can see, right-hand derivative does not equal to left-hand derivative, right?
Yeah.
So we know.
Discontinuity.
Yeah. No. That is continuous.
Differentiable.
Yeah. That
This
is
is not differentiable.
at this point, but not differentiable, right?
Yeah.
Yeah.
Differentiable.
That means the function f of x is not differentiable at the point 0, 0, right? The origin. So this example tells us a fact, and this fact we call it a theorem that is very important you should know that if a function is differentiable at a point, then we know the function must be continuous at this point. But if a function is continuous at a point, we don't know. We cannot say that the function is differentiable at this point. So now I will write the theorem here. Differentiability implies continuity. But the converse is false. So this example tells us, although the function is continuous at this point, but it is not differentiable at this point. So you should remember this theorem. That is very important. Okay, and now I will give you another example to check left and right hand derivative. Here I give you a function, the function that is a piecewise function if x is smaller than 0, then the function is sine. If x is larger or equal to 0, the function that is x. So try to find df by dx. Try to find the derivative of the function. don't forget the point 0, because from the left and from the right, it had different limit, right? So you have to consider the point 0 separately and to check if the function is differentiable at this point. Okay, for this question, I think most of you can know that if x is smaller than 0, that now df by dx that equals to d sine x by dx, right? So here, from the formula, we know that equals to cosine x. And if x is larger than 0, we know that is df by dx here equals to dx. Right? And we know that equals to 1. And now, how to calculate the point, the derivative at the point x equals to 0. So now, here, guys, we're back to this example. Here, most of you make a common mistake. Here, we know fx is not differentiable at this point. Actually, we get this result from the definition. At the point, remember the definition, that is f prime x0 that equals to limit x approaches x0 and fx minus fx0 by x minus x0. So from the right hand, you will know the right hand that equals to x approaches 0 from the right hand, from the right. And fx here, if x approaches 0 from right, fx here, that is x. And f0 is 0, right? And minus x minus 0, so we get 1 here. And from the left hand, that means x approaches 0 from the left. And here, fx, if x approaches 0 from the left, fx equals to minus x, minus 0, x minus 0. So here we get the result that is minus 1. They are different, so function is not differentiable. And here for this example, we also have to use the definition to check if the derivative exists. So here, if x equals to 0 here, you should know we have to consider the left-hand derivative and the right-hand derivative. So now we can consider the right hand. That means x approaches 0 from right. And from the definition, that should be f of x minus f0. F of x minus f0 by x minus 0 here. So here, that equals to, as x approaches 0 from the right, here, if x is larger than 0, now f of x equals to x. And f of 0 here, if x equals to 0 from here, we know f0 equals to 0, right? So that is x minus 0 by x minus 0. We can see now that equals to 1, right? And the left hand derivative, that is x approaches 0 from the left. So now, by the definition here, the function is changed. If x approaches 0 from the left, you should know here, actually, x is smaller than 0. And that means the function here should be sine x, right? So that should be sine x minus 0 by x minus 0. And here, that is the limit of sine x by x as x approaches 0 from the right. So can you remember this limit? This is the important limit. Remember that?
Yes,
yeah, so the limit is 1, right? Remember that? Limit is 1. So here, the right-hand derivative equals to the left-hand derivative. So we know the function at this point, if x equals to 0, also equals to 1 here. So we know now df by dx equals to, if here x is smaller than 0, then the derivative, that is cosine x. If x is larger than 0 or equals to 0, the derivative is 1, right? So we can get, if x is larger than 0, then that is larger or equal to 0, that is 1. If x is smaller than 0, that is cosine x. So this is the conclusion, the final result of this example. Any questions?
Laoshi, please repeat again.
Laoshi, I have a question. Where the second limit approaches the negative, which is the left, why is it that both equations are the same, but with the second one, it was equated to sine x?
Okay, sorry. Here, I made a mistake. That is minus.
Laoshi.
Yes, I know, but I mean, look at this equation.
Yes, I made a mistake here.
And this equation, they are the same. You see, they are the same, but only one is approaching from the right, one is approaching from the left. But the end results here change.
This one also is minus?
Here change.
Yes, this one also -2.
So that is my question.
Actually, I didn't totally understand your question. Your question is why this function?
Why here? You see this function is the same as, but this was equated to limit as x approaches 0 from the positive side, x minus 0 all over x minus 0. But here, as s approaches 0 from the negative side, it becomes sin x minus 0 all over x minus 0. That is what I'm trying to imply.
Because if x is larger than 0 from the function, if x is larger than 0, fx equals to x. If x is 0, fx equals to sine x. They are different functions. Yeah.
Okay, Laoshi, I understand you now.
Okay, so we have different function in this step. Okay, other questions? Sorry, here I made a mistake. Here, that is minus.
Okay, Laoshi.
And other questions about this one?
Laoshi, the result is -1 or only 1? So
Huh?
Result is -1.
-1.
Bro, there is no result.
Huh? 1. Here is 1. Just here. I should write minus here because here that is the left hand derivative. So I should write minus here. But the
it can be minus or it can be plus.
Yeah. Yeah, and the result.
You got this point?
Okay, I will make it smaller to make you see the whole question here. Okay, so any questions about this example? Especially this part. You have to take the point separately. Okay, guys, from the right. For the left and the right function has different expression. So here you have 8, both on the left and the right. So pay attention to this part. Okay, guys? No questions?
No,
Okay. So now we will have a 15 minutes break now.
Break.
Okay.
Okay, so please.
As usual.
So
yay.
Back at 35, right? 35. 50.
Yeah,
okay. Have breakfast.
It's lunchtime in Bangladesh. We already had our breakfast.
Yeah.
Now it's time to lunch.
Yeah, it's high time to feed lunch, but we don't get enough time to feed the lunch.
Break dilo কয় minute?
15 minute.
15.
তাহলে
কি আরিফুল কই থেকে আসলো? আরিফুল তো দেখি না আমি।
আরে ভাই ঘুম পাড়তাছি।
কি করো?
ঘুম পাড়ি।
আচ্ছা। বাহ, কি শান্তিতে আছে, ক্লাস করতেছে প্লাস ঘুমো যেতেছে। ভাইরে ভাই, বিদ্যাসাগর নাকি ওই মাথার চুলের ঝুঁটি দেওয়ালে বাইন্ধে রাখছে যাতে ওর ঘুম না আসে পড়ার সময়। আর তুমি ঘুমিয়ে পড়তেছো ভাই, তুমি তো বিদ্যাসাগরের হচ্ছে পুরো টেক ওভার করবা। আরিফ।
হ্যাঁ ভাই। হার্ডারে গেছে। কি না বুঝতে পারিনি।
আচ্ছা, তোমার পরে এক্সপ্লেইন করতেছি, তুমি ঘুমাও।
গেম খেলতেছি ভাই, গেম।
Hassan. Yeah.
Topo. Bro. বলো ভাই
বিদেশি বলদ গুলা এখন কথা কয় না, পরে আবার হচ্ছে গ্রুপ স্টাডিতে পক পক যায়।
বলো তো এরা কিছু বুঝে কোথায় বলদানি করবো
বুঝলেও কয় না, না বুঝলেও কিছু কয় না।
কাটা এরা
আরিফুল, তোমার বাসা কোথায়?
জামালপুর জামালপুর
জামালপুর আসবো?
আফ্রিকায়
আসো
কবে আসবো কো?
আরে আসো আসলে যে কোনো টাইম আসতে পারো
কি খাওয়াবা, ফরেন
মদ
না
খাওয়া মনে
দেশি?
আও
বিড়ি
মদ
বিড়ি
খাওয়া মদ খাওয়া মনে
বিড়ি কি, সরি মানে ফরেন না দেশি কোনটা?
ফরেনও আছে দেশি আছে কোনটা খাও
তোমার জামালপুরে বার আছে নাকি?
বার না বর্ডার পার
আচ্ছা,
সব বর্ডার পারে হ্যাঁ তবে থাক কিছু না মেয়ে আছে কিছু পেলাম না
আচ্ছা মানে ক্লাস শেষে হবে না, ঠিক আছে?
আচ্ছা
তাহলে একটু রেস্ট করো।
Wait a minute. I don't have glass in the pie. Glass, no. Huh? I don't have glass in the pie, you know.
Why everybody is so quiet?
They are sleeping.
Who are sleeping?
I'm having breakfast.
Sabir, you are having your breakfast. The gun frame.
They say, who cares if one more light goes out in the sky of a million stars? Flickers, flickers. Who cares when someone's time runs out? If the moment is all we are. Flicker, who cares if one more light goes out?
You have good taste.
What?
Bro.
And you should be. It's not fair.
I'm saying you have good taste.
Just 'cause you can't see.
Oh, I always listen to Linkin Park song when I feel depressed.
They say, who cares if one more light
Do you guys hear this song? One More Light by Linkin Park.
Flickers, flickers. Who cares when someone's time runs out? And is all we are. Flicker, flicker. Who cares if one
কি ভাই গান কই গেলে গান বাজে কি
Okay, sorry to interrupt.
আইসো
Okay.
বলদাইছে
আরে আরিফ গান শুনতেছে ভাই লিঙ্কিন পার্কের অনেক ডিপ্রেস ফিল করতেছে
কার সামনে গো বলদারের সামনে
Yeah,
বললা কি করব
please your favorite song or something
Lucky there.
to share to me.
Oh.
Share with me. Okay, let's back to class now. So before the break, we have learned the definition of the derivative of a function. So actually, the derivative of a function reflects the rates of the change of a function. For example, we have calculate that the constant function c, the derivative of this function equals to 0, and that means the rate of the change of this function is 0. That means the function does not change, right? And actually, from the graph of this function, we know that is a horizontal line, right? Maybe this is the point C. So we can see also from the graph that it is a horizontal line. That means at every point, the value of the function are the same. So that means the rate of the change of this function is 0. That's what the derivative means. So now we will learn the geometric meaning of the derivative. And the geometric meaning of the derivative, that is, if it is, for example, the graph of a function, maybe the graph is like this. The function is f of x. And this is the point x0. And after an increment, this is the point x0 plus delta x. So here you can see these 2 points, And if x equals to x0 from the function, we know that here that is f of x0, right? And here we know that is f of x0 plus delta x. And from the definition of the derivative, that is the limit f of x0 plus delta x minus fx0 by delta x. And that is delta x here, that is x, if it is x, that is x minus x0, right? So here you will see that is we can connect these 2 points to make a line. We can connect these 2 points to make a line. And the function here, the quotient here, that means the slope of this line, right? The slope of this line. And if we get the limit as delta x approaches 0, that means this point moves to x0, right? Delta x approaches 0, that means this point moves to x0. So here we got a tangent line of the function. So here, the geometric meaning of derivative here, that means the tangent slope. So here, we know that the derivative means tangent slope. The tangent slope at the point x0, at the point x0 f of x0. So that is the geometric meaning of the derivative. For example, here, if I gave you a function, the function that is f of x equals to 1 by x. So now I want to know, the tangent slope at the point to find the slope at the point.
Come on.
1 by 2. To find the tangent slope at the point 2, 1 by 2. So how to get the tangent slope? As we have learned that the geometric meaning of the derivative, that is the tangent slope. So here we just get df by dx first. So that means here, this is f of x. So that means d by dx, here that is x minus 1, right? And we have calculated before the break, that is minus 1 by x squared, right? And at the point 2, 1 by 2 here, we know here x0 equals to 2. So we know we can substitute x equals to 2 into this function to get df by dx at the point x equals to 2 equals to 1 by 2 squared. So equals to minus 1 by 4. That means the tangent slope at the point is minus 1 by 4. And also we can get the tangent line, the equation for the tangent line. Here we can also get the equation for the tangent line at the point 2, 1 by 2. So here you should know the tangent line first passes the point 2, 1 by 2 with the slope minus 1 by 4. So here we use we call it the point slope equation. I think you have learned it, right? The point slope equation, that is, we use a point and we use the slope. So that is y minus 1 by 2 equals to minus 1 by 4 times x minus 2. So here we can get that the tangent line, the equation for the tangent line.
Is it rule, Laoshi? Is it rule? How can I get it?
Okay. So I will explain. You say you don't know this one, right? Is this your question? You cannot understand the equation, right? Here, the point slope equation, that means if we know a line that passes a point, maybe this point, that is x0, y0, and we know the slope. Here I use the variable k. Here. Now,
Laoshi, got it. It comes from point slope equation rule.
Yeah, point slope equation here.
Okay.
So the point.
Got it, Laoshi.
Yeah. Okay. So I will write here in case some students didn't understand. So the point slope equation or point slope rule, that is y minus y0 equals to k times x minus x0, right? So this is the point slope equation, and we use it to get the tangent line, the equation for the tangent line of the function y equals to 1 by x at the point 2, 1 by 2. So this is the geometric meaning of the derivative here. That means the tangent slope at the point. So here I will give you an exercise to practice. That is, we know a function, the function that is t power, x power 3 So please find the equation for the tangent line at the point 1, 1. Okay, this is the exercise here.
That's what they boy. Now the boy I mean to kuru for. The to kuru na we na we no enku. It's on friend. Back to. Back up. You know it's a good. We are class. We are class.
Sakodi, please mute yourself. Sakodia.
Okay, bro.
If you have finished, you can send to the WeChat group and I will check. Okay, I think it is not hard. So first, we have to know the tangent slope of the tangent line. So first we do the we calculate the derivative of the function. So we know here, first step, we have to know df by dx. So now we know that is dx power 3 by dx. And we use the power rule here. That is 3 times x power 3 minus 1. So here, that is 3x squared. And then we know the tangent slope. Tangent slope here, that is the derivative at the point x equals to 1. So we substitute x equals to 1 into this function. So that equals to 3. So we know the tangent slope is 3. And then we use the point slope equation to get the equation for the tangent line. That is y minus 1 equals to 3 times x minus 1, right? So we know the equation for the tangent line, that is y equals to 3x minus 2. So this is the result we want, the equation for the tangent line. So any questions about this example? No, right? Okay.
Tangent slope, tangent slope. Please describe about
Tangent slope. We first get the derivative of the function. We know that is 3x squared, right?
Yes.
So the tangent slope means we have to substitute the point into this function. So that is 3 times 1 squared. So equals to 3. Because the point that is 1, 1.
Yeah.
Okay. So here we got the tangent slope, and
so for x we have to count first one. Am I right?
1. Yeah, substitute 1.
Okay.
Got
it, Laushi.
Okay. So this is the geometric meaning of the derivative. And then we will learn some differentiation rules. And these rules are very, very important for us. So the first one, we call it sum rule. Sum rule. That means if here u and v are two functions of x, and now I want to know du plus v by dx. And now we use the sum rule. The sum rule means du plus v by dx equals to du by dx.
Divided.
Yeah, plus
dv divided.
Yeah. So the first, that is sum rule. Also here, that the difference rule. That means du minus v by dx. That
du divided dx minus dv divided dx.
Yeah. So this is the difference rule. And then the second, that we call it the product rule. The product rule. That means I want to. That is u times v. Here, u and v are two functions of x. I will rewrite it again here. Dx here. du times v by dx. And that equals to u times dv by dx and plus v
into d divided dx.
dx. And if we use the prime type to write it, we always write it u times v prime equals to u prime v plus
Laoshi, I have question.
v prime. Yes.
This one, sorry.
Which one?
Oh, sorry, Laoshi, I cannot write it. And u into d or du, which one?
Here, u times v. Okay, here I will use another.
This one, u or v?
This one is v. Okay, I will use, yeah, I use another letter to write this formula. Okay. Please remove the right line. Okay, I will use another
AB
letter. I will use F and G. That will be more clear here. Here, if I want to F times G, F and G are two.
F
Yeah, here.
dg divided dx.
Yeah, F times dg by dx plus g times df by dx.
Yeah.
Yeah, it is clear now. So if we use the prime type, that is f times g prime equals to f prime g plus f g prime. So this is the second rule. We call it a product rule. And here, there is a special case. There is a special case. If one of the function is a constant function, for example, if g is a constant function,
yeah,
and here the formula that is dCf, right? dCf by dx. And now we also use this formula that equals to, follow me guys, that equals to C, right? C times df by dx plus f times dc by dx, right? Can you follow my steps? We use this product rule. And here, g is a constant function, c is a constant, c here. So here you can see that the first part, that is d times df by dx, right? And plus the second part here. Do you know dc by dx equals to dc?
0.
Yeah. C is a constant, right?
Yeah.
C is a constant. So here, dc by dx, the derivative of a constant equals to 0, right? We have proven it. So that is f times 0 equals to 0, right? So here that equals to c times df by dx. Can you follow my steps?
Can you repeat, Laoshi, this one?
Second. Okay, here. If here g is a constant function.
Yes.
So g is a constant, c is a constant here. I want to know d c times f by dx, and we use the product rule. that equals to d times df by dx. The
Yes,
derivative one by one, right? And
Yes.
plus f times dc by dx. And here, because c is a constant, so dc by dx equals to 0. So this part equals to 0. We know that df by dx equals to c times d.
Your sound is buffering, Laushi.
Sorry?
Your sound is buffering.
So here I will give you an example. For example, here, I want you guys to calculate d 5x by dx. So you should know here 5 is a constant, right? So that equals to 5 times
dx divided by
so that equals to 5, right? Because yes, because the derivative of x equals to 1, right? Another example, for example, I want you guys to calculate d 2x squared by dx. So that should be equal to 2 times
dx squared by dx.
By dx. So you should know that equals to 2 times 2x, right?
Yeah.
Equal to 4x. So actually,
Laushi, why will we use first bracket on dx square on x square?
Sorry, I use what?
Why we use this bracket? This one. Why we use this one?
Because here I want you to calculate d2x squared. Of course,
d divided dx is 5.
Of course, you can calculate it directly by here 2x squared. But our formula, that is x power n prime, right?
Yeah.
Yeah, the constant before x power n, that is 1, right? So we use this product rule. Then we can use the formula. Can you understand now?
Yeah.
Okay. So here, actually, if c is a constant here, we know we can just take this constant outside, right? And to do the derivative of the function. Then don't forget to time the constant at last. Okay? So this is the second rule, product rule. And then the third rule, that is the quotient rule. The quotient rule.
d divided dx.
Yeah. That means I want you to calculate
Divided, u divided b.
U by v, or here to make it
F
clear,
divided g.
I will write f by g here, okay? So that equals to here, that is g times df by dx minus f times dg by dx over g squared over g squared. And usually we can write it as f by g prime equals to f
G F
prime g minus f g prime by g squared.
Yeah.
Yeah. These two expressions are equivalent. So you have to remember the quotient rule. And maybe it is a little bit complicated. So you have to spend more time to recite this quotient rule. So here I will give you yeah, I will give you an example here. Okay, what is your question?
Okay. After the example, then ask my question.
Okay, I'll give you an example here.
Okay.
We have learned the formula that sine x prime, or you will write d sine x by dx equals to cosine x and d cosine x by dx equals to minus sine x, right? We have read the formula above these two. So now we want to find the derivative of the function tangent x.
Okay.
Tangent x by dx. Okay, so now you first know that tangent x equals to sine x by cosine x, right? Tangent x equals to sine x.
Right, Loshi.
Yeah, so here we will use the quotient rule to get the derivative of the function tangent x. So that equals to here.
Cos x.
Yeah, so here
Cos x
cosine x times
d divided dx
d sine x by
divided dx.
Then minus sine x times d
Cos x divided dx.
Yeah, and here that is cosine
X is square.
right?
Yeah.
And we will calculate as here cosine x times here d sine x by dx equals to cosine x, right? And minus sine x times here d cosine x by dx equals to minus sine x. And then over cosine x squared. So now you will know that is here cosine x squared. Here minus makes plus, right? Sine x squared by cosine x squared. So do you know cosine x squared?
Sin square equal 1.
Yeah. Plus sine x squared equals to 1, right? So that is 1 by cosine x squared. And remember that we have learned that secant x equals to 1 by cosine x, right? So that equals to secant x squared. So we have another formula. This is number 9, maybe. Number 9. So d tangent x by dx, or you can write tangent x squared equals to here sec x squared. So you can plus this formula to the formulas I listed above. Okay, this is number 9. d tangent x by dx equals to secant x squared. We use the quotient rule here. Any questions?
It's Loshi, I'm lost.
No, Laushi.
Okay.
Who's lost? Sakori.
Yeah, I'm lost, bro.
There are too much
I
math
think we
in this class, Laushi, today.
Yeah.
this is so easy.
Too easy. Okay.
Who said it is easy?
Me,
Let them
Nahi.
take their easy.
As well as Hassan.
Okay. So now I will give you some exercises to check if it is really too easy. Okay. So here, number one.
I think we will have questions after.
That the questions are the same to find the derivative of the function. Okay, number one, the function that is minus x squared plus 3. The second, so first complete the 4 questions. And then I will give you more.
We have to do it right now.
Yeah. Did it right now.
Oh my gosh. Okay, Laushi.
I thought you said it was easy.
Don't worry, this is so simple.
Don't worry.
I never ever say it is easy.
Somebody send me, I'll copy.
I don't know who says it's easy.
Okay.
But it's not me.
We just use.
You guys got it wrong.
The formulas I gave you before the break, right? And the differentiation rules we just learned. For example, the sum rule, difference rule, product. We didn't use product here, right? And quotient. So the first 4 questions actually are easy. So try to complete it by yourself.
I'm feeling mountain pressure on my head, Laushi, to solve this problem.
Okay, so if you have finished, you can show me your procedure. There is not enough time to check one by one, but I have checked some students, and I see most of you did well here. So I think that is not difficult. So we will give the solution directly for the first one. For the first one, that is, we have to get y prime, and that equals to minus 2x plus 0, right? Here we use the sum rule. So we have to calculate the derivative part by part. And the first part, we know the derivative, that is minus 2x. And the second part, it is a constant. So the result is 0. So we have the first, that is minus 2x. And the second, here, we also use the sum rule. So we have to calculate it part by part. So here, 3 parts. The first, that is 2x, right? And the second, that is 1. The third is 0, right? It is a constant, don't forget it. So that equals to 2x plus 1. And the third one, the function, you will see that here is a constant times x power 3. So here actually y equals to 4 by 3 times x power 3 minus x, right? So here we can use the product rule here. This one, here. We can use this rule, right? So that equals to y prime equals to 4 by 3. It is a constant. So we write again here, times the derivative of the function x power 3. So that equals to 3x 3 minus 1, so squared, and minus 1. So that equals to 4x squared minus 1. And of course here, for this function, 4x power 3 by 3, it can be regarded as a quotient, right? So you can use the quotient rule. But you will find that quotient rule is a little bit complicated, right? So here we just regard it as a constant times a function, and it is easy to calculate. And the last one, number 4, that is y prime equals to the first part constant, so 0. The second part minus 2x, so minus 2. And the last part, that minus here, this part, we have practiced this type of function above, right? So here that is x power minus 3. So here that is minus 3x power minus 4. And usually we write like this, like minus 2 plus 3 by x power 4. So here are the solutions for the 4 examples. So any questions?
I did not understand, Laushi. How to do get minus 3 into x power 4 minus 4?
Oh, which one?
This one.
Here, number 4.
Yes, number 4.
Yeah. Here you don't understand how I get x power 4, right? Here, x power minus 3. If I want to calculate derivative of x power minus 3 by dx, that equals to, here, n equals to minus 3, right? So we use the formula that equals to minus 3 times
Yes.
X over minus 3 minus 1.
minus 1. So we have minus 3 times x minus 4. This part.
Okay.
I said
Got
it
it,
is
Lakshmi.
easy.
Okay. Any other questions? No? So if you can understand these 4 questions, please text one in the WeChat group. Okay, guys, let me know how many of
Now
you.
she
Yeah?
only the number 3. Only the number 3, the product rule.
Number 3, product rule. Here. It is
Okay. This is how.
sorry. Sorry, I cannot hear clearly. Sorry.
This is how I am assuming it. Look at what I'm doing on your screen. This is how I assume you got. Is that so?
Yeah. 3 can be cancelled.
Okay. Okay, Lashi.
Okay.
Okay.
So many ones. That means you have understood well, right? Okay. Okay. We will practice some questions which are a little bit more difficult. Okay. So number 5. The question that is y equals to ex times sine x. And number 6, y equals to x squared plus 2 power x minus 2x plus 2. And number 7, that is y. Y equals to 2x plus 5 over 3x minus 2. The last one, number 8, y equals to x power 3 minus 4 cosine x minus ln 2. Okay, so try to solve these 4 questions.
My gosh, another 4.
Practice makes man perfect.
Yeah, if you want to learn math well, you have to practice more. Maybe that is the only way, and that is the easy way to learn it well.
Mm-hmm.
I see about 20 students reply 1 in the WeChat group, and here are 45. students here. So that means more than half students cannot totally understand the first 4 questions. And actually the first 4 questions here, they are very, very basic questions for calculating the derivative. So guys, you have to practice more. And after the, in the book, in the Thomas Calculus, the book, you will find many exercises. So practice more. At least to make it understand, to make these types, the first 4 questions, you can understand and calculate correct. And they are really basic.
Lovely. Don't see the question. Yeah. Right.
Don't hurry to check one by one, part by part, if you have done it correctly. Check the quotient rule again. The quotient rule F over G, that is here, df by dx times G. So first calculate the derivative of F and minus the derivative of G. So pay attention to the order, the quotient rule. Okay, let's solve the questions together. I think number 6 is easy, and then number 5, then number 7, and then number 8. Actually, number 8 is very easy, but many students made mistakes here. So let's solve it together. Number 5. Number 5 here. Ex is a function. Sin x is another function. So here, they are two different functions. We have to use the product rule here. We have to use the product rule here. So number 5, dy by dx here, that equals to sin x times dx by dx. Then plus here, ex times d sin x by dx, right? So that equals to sin x times here, dex by dx, we have the formula that equals to ex. And plus here, ex times d sin x by dx equals to cosine x, right? So here, this is the result. Or if you find here are the common factor ex, right? So you can also write like ex times sin x plus cosine x. Okay, so this is the result of number 5. Any questions here? So you have just to remember that here are two functions. So you have to use the product rule here. So this is number 5. And number 6. Number 6. Here I want to calculate dy by dx. So don't forget to calculate it part by part. So the first part, I think that is easy, 2x, and plus the second part here, that is 2 power x. So here that equals to 2 power x times ln 2. Here we have the formula. Here you have to write ln 2 here, not log 2 here. Okay, guys, pay attention this part. And then minus 2. And the last part plus 2. 2 is a constant, so plus 0. We don't write it. So this is the result of number 6. Any questions? No? Okay. So number 7. Number 7. Number 7, we have to use the quotient rule, right? And here, dy by dx equals 2. Okay, we know here that is 3x minus 2 squared. So we write it here. You don't have to write it part by part. Just leave it here. It is okay. And then we use the quotient rule here. That equals to 3x minus 2 times d 2x plus 5 by dx, and minus 2x plus 5 times d 3x minus 2 by dx, right? So here we know that is here d 2x plus 5 here, that equals to 2 here. This part equals to 2. Can you understand, guys? And this part equals to 3. So we know that equals to 2 times 3x minus 2 minus 3 times 2x plus 5 by 3x minus 2 squared, right? So after simplifying, we have that equals to minus 19 by 3x minus 2 squared. So this is the result of question number 7. Any questions? No here? Okay.
Yes, Laoshi.
Okay.
Laoshi, why is it that the denominator is not being differentiated or simplified?
I
want.
Just here we just use the quotient rule. So you have to remember quotient rule very clearly. And the quotient rule here, that is, maybe you can write like this: d d f over g, right? That equals to g squared here, right? And then here, here that is g times df by dx. So first we calculate df by dx and minus f times dg by dx. So first part, g here, that is 3x minus 2, right? So we write 3x minus 2 squared here. And then here, df by, and f is 2x plus 5, right? So that is d 2x plus 5 by dx. And here, d 2x plus 5 by dx. We have to calculate part by part, right? First part, 2x. Second part, 5, right? And 2x, we know that equals to 2. And 5 constant, so plus 0. Yeah, so here we get 2. We get 2 here. Okay, and similarly, we have d3x minus 2 by dx equals to 3. So we have this step. And then we just simplify it. Here, that is 6x minus 4 minus 6x minus 15, right? And 6x can be cancelled. So here, that is minus 19 by 3x minus 2 squared.
Okay.
Okay. Other question? No? Okay. So come to the last question, number 8. Number 8 here. Also, we have to calculate this function part by part. And for the first part, first 2 parts, I think that is not difficult because we have the formula. And here, many students make mistakes here. Ln 2, you have to make it clear. Ln 2 is a constant or a function. Many students write ln 2 prime equals to 1 by 2 because maybe she or he thinks that we have learned that ln x prime equals to 1 by x. So ln 2 prime equals to 1 by 2. Is it correct? Guys, is it correct? You have to know here.
Yes.
You have to know here, ln 2 is a constant, right? It's a number. So,
yes, it's a constant.
Yeah,
Yes.
so ln 2 prime equals to 0 equals to 0. It is a constant as,
Zero.
yeah, as for example, the value 1, 2, 3. So the derivative of the constant equals to 0. And here, only ln x, the function, here prime equals to 1 by x. So can you understand, guys? If here I write minus ln x, of course, the derivative you will write minus 1 by x, right? But here, if I write minus ln 2, it is a constant. So you cannot use the formula. Just write 0 here and we can ignore it. So here you should pay attention to this part. Of course, I can write, for example, ln 10, minus ln 10 or plus ln 10. It is after the calculating, it is 0, right? Because it is also a constant here. So you have to know it that ln 2 is not a function, it is a constant. So if we have make it clear, then number 8 is easy. So dy by dx, that equals to dx power 3 by dx minus here 4 times cosine x. So we can take the constant 4 outside and then times d cosine x by dx. And then minus 0, right? Because it is a constant. So that equals to 3x squared minus 4 minus sine x, right? From the formula, and minus 0. So we can get the result. That is 3x squared plus 4 sine x. So this is the result of number 8. Any questions? No?
No.
No.
Okay, no question, right? And and today we have learned the definition of the derivative and how to calculate the derivative. First, the first way we can use the definition, but most of the time we will use the formula, right? And we have listed 9 formulas today. So you have to remember the 9 formulas very clearly and use it directly to calculate the derivative. And then we have learned the geometric meaning of the derivative. That means the tangent slope at a point of the function, right? And finally, we have learned the differentiation rules. And for these rules, they are very important because we will use the rules to calculate some complicated functions. So you have to remember the rules as well as the formulas very, very clearly. Pay attention to the quotient rule because here are the order. It is very important, and don't make it confused. So here are the things we have learned today. And next we will continue to learn the derivative. And next week,
Nahid, turn off your mic. Nahid.
and next week we will learn more complicated rule. So you have to practice more, and I will leave you homework today. And I will send the homework in the WeChat group tonight. Okay, guys? And you have to
Okay.
submit your homework. And this is the second homework, right? So
Yeah.
submit your homework before next Thursday. Okay? To
Next
my email.
Thursday.
Yeah, next Thursday.
Laushi,
Okay,
please
Laushi.
make sure you give us the easy one. Don't give us the toughest one, Laushi.
I will give you both the easy one and the tough one. Okay. So try to practice, but I will not give you very difficult ones. So take it easy.
Okay, Lord.
Try to use the
Okay, Lord.
formula and try to use the differentiation rules. Okay, guys?
Okay.
Okay,
Laushi.
Laushi.
Okay, so that's
Okay,
all
Laushi.
for
Okay,
this
Laushi.
class.
Is this the quotient rule or the product rule?
Quotient rule. And number 2 is the product rule.
Quotient. Okay, quotient.
Okay. So see you next week, guys.
Okay.
Okay, Laushi.
Kaijan Laushi.
Okay, Laushi.
Bye-bye.
Bye.
Okay.
Laushi, এর আগে আপনি মরে
Bye.
যাবেন।
Okay, bye.
Jadian, Laushi, Jadian.
Bye, Lausche.
I am going to depressed.
Why?